Hello everyone. Let us begin session 2 of module 1. Here we will be discussing about precipitation, forms of precipitation and types of precipitation. So what is precipitation? How do we define precipitation? All forms of water that reach the Earth's surface from the atmosphere is called precipitation. It is nothing but any form of moisture reaching the Earth's surface. It is also defined as return of the atmospheric moisture to the ground in the form of solid or liquid. Precipitation is the fall of water in various forms on the Earth's surface from the cloud. So these various forms include rain, snow, hail, drizzle, which we will be dealing in the latter part of the session. Now, coming to the main characteristics of the rainfall, we know the amount or quantity of rainfall is very, very important. The amount of rainfall is usually given as a depth over a specified area. We assume that all the rainfall accumulates over the surface where it falls. The unit for measuring this amount or quantity of rainfall is centimeter. The volume of rainfall is nothing but the product of area and depth of rainfall. The amount of rainfall is usually measured with the help of rain gauges. Moving on to the intensity. This is usually average of rainfall rate during the special periods of a storm and expressed as centimeter per hour. So amount or volume is given in centimeters, but the intensity is given in centimeter per hour. Moving on to the duration of storm. In the case of a complex storm, we can divide it into a series of storms of different durations. Again, it depends on the intensity, whether it is more or less or a uniform intensity. Coming to the areal distribution, during a storm, the rainfall intensity or depth will not be uniform over the entire area. Hence, we must consider the variation over that area. The areal distribution of rainfall over which the rainfall is uniform throughout. Moving on to the formation of precipitation. Precipitation occurs when the following four conditions are satisfied. Cooling of air mass. The cooling occurs when the air ascends, that is, moves from the Earth's surface, to the upper level in the atmosphere. The second condition, the formation of clouds into ice crystals due to condensation. So, condensation occurs when the water vapor in the atmosphere is converted into liquid droplets or into ice crystals when the temperature is quite low. Now, once those water droplets are formed, their growth plays an important role. So the size of water droplets in a cloud is usually very small. It is less than 0.1 mm, 0.02 mm, which cannot reach the ground unless there is growth in water droplet. So what it means is the tiny water droplets which will be formed in the clouds, they need to colloidal suspension has to take place there with the help of wind speed and turbulence. Then they come together, they form bigger droplets. That is what is known as growth of water droplets. So only if their size increases, then they can precipitate back to the earth. Accumulation of moisture. So the air must contain sufficient amount of moisture for this condensation to occur, and thereby when this process completes, then the process of precipitation can occur. The same formation of precipitation also needs these certain conditions. Whenever the water rises into the atmosphere as water vapor, it needs to get condensed to form clouds. So for that condensation process to occur, the atmosphere must contain sufficient amount of moisture content. Once sufficient amount of moisture is present, the water vapor condenses over the nuclei which are present in the atmosphere to allow the process of condensation. So what are these nuclei? They are the salt particles. They are the results of combustion process. So when sufficient salt are present, the water vapor will condense over the nuclei to form clouds. Then the condensation process happens. The weather conditions must support the condensation process. Yes, I said sufficient moisture must be present. The nuclei should be present so that the water vapor in presence of moisture will condense over the nuclei to form the clouds. So when clouds are formed, the tiny water droplets are present in these clouds. But the tiny water droplets to be formed need good weather conditions. The wind speed, the turbulence play an important role. Finally, once condensation is over, the tiny droplets have formed bigger water droplets. They precipitate in the form of precipitation. Now, this precipitation or the product of condensation must reach the Earth's surface. So before reaching this Earth's surface, everything gets evaporated. There is no meaning. So it has to reach the Earth's surface. In this way, these conditions play a very important role to form precipitation. Now, how this precipitation occurs. So we know water is present in various water bodies. So it can be lake, river, pond, ocean, etc. So the water from these water bodies starts evaporating in the presence of heat energy, solar energy, sun's energy, solar radiation. You can use any word. So it starts getting evaporated as water vapor. This water vapor starts moving up into the Earth's atmosphere. It gets collected in the atmosphere and behaves like a gas. Once it reaches there, it behaves like a gas. It goes on increasing. It increases to such an extent that the space can no more hold that water vapor. And finally, a stage is reached when this water vapor has to get condensed. For that condensation, you need sufficient amount of moisture in the atmosphere as well as the salt particles, the nuclei. That is the result of combustion. They are the salt particles. So this stage is reached where the space can no more hold that water vapor. It has increased to such an extent. Now, in presence of moisture, it gets condensed over the nuclei to form clouds. Now, once the clouds are formed, the clouds contain tiny water droplets of size less than 0.1 mm. And this size of water droplets cannot precipitate. It cannot fall back to the earth. it has to grow in size. Now, to increase its size, the wind speed, its turbulence play a very, very important role. So the wind speed with high turbulence allows the movement and the colloidal suspension of these tiny water droplets which are present in the clouds. Now these tiny water droplets, because of wind speed with high turbulence, they come together and form larger water droplets. And these larger water droplets cannot remain in the clouds, and hence they precipitate, and they result in the process of precipitation. Thus, the water comes back to uh, to the earth's surface in various forms. The form can be rain, snow, drizzle, hail, sleet, glaze, any of the form. Thus, the net precipitation which occurs on the Earth's surface mainly depends on various factors such as temperature, wind, humidity. Let us move on to the forms of precipitation. So we have various forms of precipitation. The first form is drizzle. So many a times we use the word drizzle. It is drizzling. Sometimes we use it is raining. So there is a difference between drizzle and rain. So if there is a fine sprinkle of numerous water droplets, then we call it a drizzle. So drizzle is a form of precipitation which consists of water droplets of diameter less than 0.5 mm or 0.05 centimeter with intensity less than 0.01 centimeter per hour or 1 mm per hour. It is a fine sprinkle of numerous water droplets. In this, the drops are so small that they appear to flow in the air. Thus, we call it a drizzle. So this is a form of precipitation. Now coming to the second form of precipitation, rainfall. It is nothing but it is the water drops which are larger than 0.5 mm or 0.05 centimeter. That is the dia of that water droplets up to 6 mm dia or 0.6 centimeter dia. The water drops of size greater than 6 mm or 0.6 centimeter dia, they tend to break up as they fall through the atmosphere. The intensity varies from 0.25 centimeter per hour to 0.75 centimeter per hour. So depending upon this intensity, so it is 0.25 centimeter or 2.5 mm per hour. We differentiate the rain as light rain, moderate rain, and heavy rain. So when the intensity of the rain is less than 2.5 mm per hour or 0.25 centimeter per hour, it is known as light rain. When the intensity is 2.5 mm per hour up to 0.75 centimeter per hour, it is known as moderate rain. And when the intensity is greater than 0.75 centimeter per hour or 7.5 mm per hour, it is known as heavy rain. Coming to the third form of precipitation, it is snow. This is a precipitation in the form of ice crystals. These crystals carry a thin coating of liquid water and form flakes. So it is in the form of flake when they collide with each other. So these flakes are nothing but it is snow. The next form of precipitation is hail. So we all are aware of this hailstone. When we say there was a hailstone shower last night, it means we had lumps of ice or ice crystals. So this is a showery precipitation in the form of lumps of ice of size greater than 5 mm or even greater than 8 mm. It is called a hail or hailstone shower. Coming to glaze, the next form of precipitation. This is the ice coating formed when a drizzle or rainfall comes in contact with very cold objects on the ground or the cold ground. Means the ground surface is very cold, it is below 0 degrees Celsius. So the rain or the drizzle which falls on it forms a ice coating, and that is known as glaze. The next form of precipitation is sleet. So sleet is a form of precipitation where it results because of melting snow. It's a mixture of snow and rain. It is in the form of pellets, or even we say transparent grains which are formed. So the diameter lies between 1 mm to 4 mm. So these are frozen raindrops. They form transparent grains when the rain falls through the air at sub-freezing temperature. Moving on to the next form of precipitation, frost. It's a feathery deposit. It's a form of precipitation which occurs in the form of scales, needles, feathers, or fans. So we usually say the feathery deposit makes up the frost. Moving on to the next form of precipitation, that is dew. Dew is a form of precipitation which doesn't occur because of condensation in higher layer of atmosphere, which means the water droplets or the water vapor gets condensed in the higher layer of atmosphere to form clouds. But this dew is something where that condensation doesn't happen in the upper layer of the atmosphere, but it condenses on the ground surface. It is formed by the condensation directly on the ground at the ground surface. Dew occurs in the night when the ground surface is cooled by outgoing radiation. So because of that cool temperature, the moisture gets condensed. The water vapor at the ground surface gets condensed, and you can see these dewdrops on the surface of the leaves early in the morning when you observe it. Moving to ninth form of precipitation, that is fog. Fog is nothing but a thin cloud which is formed at the earth's surface by what? By condensation process of atmospheric vapor which may be of varying size. So this fog usually hinders our visibility. The visualization is going to be obstructed. So we usually see this fog in high altitude areas. It restricts the visibility to a few kilometers because it is thick. Coming to mist, a very thin fog is known as mist. So it is a very thin fog. Fog is a thin cloud, but mist is a thin fog. Here, the visibility is hindered to a very short distance. We can see immediately after a certain distance. But in case of a fog, longer visibility is hindered. So in this way, all these 10 types, that is drizzle, rainfall, snow, hail, glaze, sleet, frost, dew, fog and mist are different forms of precipitation. Moving on to different types of precipitation. So the first type is convective precipitation. Second one is orographic precipitation and cyclonic precipitation. So let us discuss about convective precipitation. This is due to the lifting of warm air masses which is lighter than the surroundings. Generally, this type of precipitation occurs in the tropics where on a hot day the ground surface gets heated unequally, causing the warmer air to lift up, and precipitation occurs in the form of high intensity and short duration. So, during summer days, when the days are hot, the temperature is hot, the ground surface gets heated up, hence the air is warm there. It starts moving up when the cool air rushes in horizontally. It lifts this warm air, and this warm air starts moving up, and in presence of sufficient amount of moisture, it condenses over nuclei to form the clouds by the process of condensation, and then later on precipitates back to the earth's surface. So usually this happens during summer season, in hot days when the temperature is great, high, the ground surface becomes hot, the air becomes warmer and starts moving up. So the lifting of air mass is caused when the cool air rushes in horizontally, takes its place, and the warmer air moves up. There it gets condensed to form clouds and precipitates back. So such precipitation occur in the form of high intensity rains, and they are usually of short duration. So you all can see the figure here. So there's a hot surface, warm air is moving up, the moist air, the cool air rushes in horizontally, takes its place, the warmer air starts moving up, and in presence of sufficient amount of moisture in the atmosphere as well as nuclei, this air condenses over the nuclei and forms the clouds. The clouds precipitate back. And this type of precipitation is known as convective precipitation. Moving on to the next type of precipitation, it is orographic precipitation. It is one of the most important precipitation. It is responsible for most of the heavy rains in our country, India. How is this precipitation caused? It is caused by air masses which strike some natural topographic barriers like mountains, and they cannot move forward, hence they start rising up. The rising amount causes precipitation. The greatest amount of precipitation falls on the windward side, and the leeward side has very little precipitation. So, there are various mountains, there are various topographical barriers which are present on the surface of the earth. As the wind mass or the air mass starts moving, because of this barrier, it gets obstructed. Hence, it starts moving up, rising up. It rises, reaches the Earth's atmosphere. Again, in presence of moisture and nuclei, condenses to form clouds. The process is condensation, and it precipitates back to the Earth. So this lifting of air mass, because it is obstructed by various topographical barriers, leads to condensation and precipitation, and this is known as orographic precipitation. One more most important part is the greatest amount of precipitation falls on the windward side, which means this air which strikes the topographic barriers moves up, forms clouds. These clouds precipitate back in this area, and that area is known as windward side because the wind moves here. But the back portion of the mountain is known as leeward portion, leeward side, and this receives very little amount of quantity of precipitation. Such a precipitation which occurs because of such topographical barriers, they make the air mass to move up, rise up, get condensed, and they precipitate back, which is known as orographic precipitation. Moving to the last type of precipitation, that is cyclonic precipitation. We all know what a cyclone is. It is a large whirling mass of wind. So why this large whirling mass of wind is formed? It is because of the barometric pressure which is low at the center. So the pressure is measured using the instrument barometer. So we call as barometric pressure. So when low barometric pressure is there, the air mass moves up. So lifting of air mass happens. So this lifting of the air mass condenses to form clouds, which precipitates them. And hence it is known as cyclonic precipitation. So this is the precipitation which is associated with cyclones or moving masses of air and involves the presence of low pressures. A cyclone is a large zone of low pressure which is surrounded by a circular wind motion. So circular wind motion is nothing but whirling mass of wind. Cyclone is a whirling or a large whirling mass of wind with huge diameter and great velocity. So when such a thing happens, the warm air starts rising up because of that low barometric pressure at the center. The cold air or the cool air rushes in horizontally. It takes its place, and this air, due to low barometric pressure, moves up, condenses, forms clouds, and precipitates back to the Earth's surface, which is known as cyclonic precipitation. Now, this is further divided into two categories: non-frontal cyclonic precipitation and frontal cyclonic precipitation. What is non-frontal cyclonic precipitation? If low pressure occurs in an area, that is cyclone. Cyclone is a large whirling mass of wind. So it's a circulating wind where the air will flow horizontally from the surrounding area, that is from a high pressure. It fills this low pressure area, and that makes the air in the low pressure area to lift. This starts rising up. It cools down at higher altitude in presence of moisture and condenses over nuclei to form clouds, which precipitates in any of the form. This is known as non-frontal cyclonic precipitation. Moving on to frontal cyclonic precipitation. Rain is caused by cyclonic activity and it occurs along the fronts of the cyclone. It is formed when two masses of air of different temperature, humidity, and density meets. So this type of cyclone occurs when one air mass rises over another air mass, which means an air mass will have been lifted up. The second air mass moves and overtakes it. It condenses, forms clouds, and causes precipitation. So these two air masses which are formed, they have different temperature, different humidity, and different density. They meet each other, and the boundary of these air masses is known as front. That is the layer which separates these two air masses. It's known as a front or frontal surface. For example, meeting of moisture-laden warm tropical wind with polar air mass. That is, the wind which blows from tropical region and air mass from a polar region. When they meet each other, they have total different density temperature. They overtake each other. They replace each other. One air mass lifts over another air mass and it condenses to form clouds and precipitates back, which is known as frontal or cyclonic precipitation. Now we also have something called as a cold front, a warm front, and an occluded front. So what is this cold front? A cold front is that in which a warm air replaces the cold air. Next, a warm front, it is that in which a cold air replaces the warm air. An occluded front is that when the cold front overtakes the warm front. So these two air masses, the boundary is known as a front, a frontal surface. So warm air replaces cold air in a cold front. A cold air replaces warm air in a warm front. A cold front overtakes warm front, and that is known as occluded front. And now the last type of precipitation, which is known as turbulent precipitation. This precipitation is usually due to a combination of several of the above cooling mechanisms, that is lifting of air masses, the change in frictional resistance as warm and moist air moves from the ocean into the land surface may cause lifting of air masses, and hence the precipitation occurs on cooling. This precipitation results in heavy rainfall. The winter rainfall in Tamil Nadu is mainly due to this type of turbulent ascent or turbulent movement of the air masses, and that is known as turbulent precipitation. Thank you.